Welcome back, Math 30-1. Today we are going to look at combinations. So we're just going to skip ahead here to what is a combination and how does it differ from a permutation. So here's an example I like to think about. If there's like a raffle and they're picking 10 names from a hat and everyone who is picked gets $100, it doesn't matter if you're picked first, second, third, or last, the 10 names picked gets $100. That is an example of a combination. A combination is where we're doing selection and order is not taken into account. So order selection is not taken into account. But now let's say we're doing a same style raffle, it's just as much money, and they're taking 10 names, but let's say the first name picked gets 500. Second name picked only gets 400. Third name picked gets like 50, and then so on like that. Well, that matters on the order you are picked. That is a permutation because the arrangement of picking matters. So arrangements or the order is very key for permutation, where combination it is not. That is the main difference, okay? So here we're going to go on to our first example right after we go over our combinations formula. So, my combinations formula here says anytime we have something, it is n factorial divided by n subtract r, which is the amount we're picking, multiplied by r factorial. The reason why is there's less, if the order doesn't matter, there's a less amount that we need, and that's why we're going to also divide by that extra r factorial. This is also nice as it is in your calculator. Right here, if we push the math button, and then we go over to probability, it's right here, and this is our, that's our combinations function in our calculator. Okay, so here, let's take a look at our first example. It says 3 students from a class of 10 are chosen to go on a school trip. So when we look at this, it doesn't matter if you're the first one chosen, or the third one chosen, or the second one chosen. If you're chosen, you're on the trip. So that means it's automatically a combination. So how many ways can they select the children? Okay, write your answer in factorial form and in notation form and then evaluate. So basically when we look at this here, we have a total of 10 children and we're only choosing 3 of them. Okay, so that is the same as 10 factorial all divided by 10 minus 3 factorial multiplied by 3 factorial, which is the same as 10 factorial all over 7 factorial and 3 factorial. Okay, and that gives me a total of 120 different ways. So confirm this by using the strokes on the calculator. So I'll show you the strokes on the calculator here. So I'm going to start off with, we type in 10. Now I'm going to hit the math button right here. We're going to go all the way over to probability. So that's number 3. And we are choosing 3. We push enter and I get 120, the exact same answer. Okay, so now it says class example number 2. The Lotto 649, to win the Lotto 649, a person must correctly select 6 numbers between 1 and 49. Jasper selected the 6 numbers from the birth dates of his family. So we have 3, 7, 9, 11, 20, and 29. How many different selections of numbers could he have made? Okay, so now we have 49 different numbers to choose from. From 1 to 49 gives me 49 different numbers. Now, we're only going to choose 6 of them. So if we plug that into our calculator, just going to check that out here, I'm going to put in here, we're going to put in 49, hit the math button, and we're going to go all the way over to probability, and it's number 3, 49, choose 6, enter, and I get 1,000, I'll just punch that, put that in here, we end up getting 1398386. Okay? All right, so now the next one says the athletic council decides to form a subcommittee of 7 council members to look at how funds are raised and should be spent on sports activities in the school. There are a total of 15 athletic council members, 9 males and 6 females. The subcommittee must consist of exactly 3 females. Okay? So determine the number of ways of selecting only the females. So if we're only selecting the females, there's a total of 6 females and 3 must be there. Okay? And then we have 9 males. So we have 6, 3, which will give me a total of 20. Okay? Now, what's a way of selecting the males? Okay? So, of selecting the males then, out of 9 of them, we have then to choose 4 males. Because if it's exactly 3 females, that must mean we can only have 4 males. Okay? So, that is going to give me a total of 126. Okay? And now, what is the total thing for the subcommittee? Well, we have females and males. It's not females or males, so it's females and males. Keyword is and. That means we're going to multiply these two together. So it's 6 combination 3 multiplied by 9 combination 4 is equal to, multiply those together, which is 20 multiplied by 126, which will give me a total of 2520. Okay? So, now B says, how many ways can the subcommittee be selected if Bruce, the football coach, must be included? So now, if Bruce, the football coach, and we're going to assume he's part of the council, he must be included. That means out of the males, we only have, out of 8, we could only choose 3. And that means still the females, out of 6, we are choosing 3 as well. Okay, because Bruce must be included. So this is my males, and this is my females. We multiply these together. So when we put that into our calculator, I'm going to end up getting 20 for the females, as we found out in the question before. And the males is going to end up giving me a total of 56, which is, altogether, we end up getting 120 as my solution. So 1,120 different combinations. Okay. Last example. So here he says, we're just going to go over what a deck of cards is first. So in a deck of cards, we have 52 cards. We have 4 suits, which are spades, clubs, diamonds, and hearts. Each suit has 13 cards. 2 of the suits are black, so that's half of the deck's black, which are the spades and the clubs. 2 of the suits are red, which means half the deck are red, which are the diamonds and hearts. And 5 cards, or face cards, are considered to be the jack, queen, and king. Now, in a poker card game played from a deck of 52 cards, we normally take 5-card hands. So, it says, how many different 5-card poker hands are possible? So here's another hint with poker. The order of cards, or like the order you get your cards, doesn't matter. All that matters is what cards you have. Okay? So out of 52 cards, we want a 5-card hand. Okay? Which gives me a total of, if I plug this into my calculator, we want out of 52, we are going to choose, or we want a combination of 5, which gives me that there for our number. So that's going to be 2,598,960. Okay? Now it says, okay, so now we're looking at B. How many hands will there be? All diamonds. So diamonds is going to be, there's 13 in each suit. So out of 13 cards, we want 5 of them to be diamonds. So that's going to be equal to 1287. Okay? Now, next part here is saying 4 cards are black and 1 card is red. So black is half the deck, So that's 26 is half of 52, and we want 4 of them are black, and then out of 26 red, we want 1 of them to be in the hand. So we multiply these together because it's this and that, and that will end up giving me 14,950 multiplied by 26, which is the same as 388,700. Okay? Now the next one says 3 kings and 2 queens. So there's only 4 suits and there's a king in each suit. So out of 4 kings, we want 3 of them, and out of 4 queens, we want 3 of them. Or sorry, 2 of them as well. Since we're saying and, we have to multiply these together. So that's going to be the difference of 4 times 6, which gives me a total of 24. Okay? Now, this one here says 3 kings. So the only stipulation is 3 kings. So out of 4 kings, we want 3 of them. And now it says we have then 2 of any other card, but they're not kings. So if we take out the 4 kings, there's only going to be 48 cards left, and out of those we want 2. Okay? So that's 3 kings and 2 non-kings. So we look at this here. This is going to be the same as 4 multiplied by 1,128, which is the same as 4,512. Okay? The next part here wants 4 aces. So there's 4 of each number. So that's out of 4, we're choosing 4. Okay? And that would mean out of 48 other cards, because we have non-aces now to select from, that means we want 1 non-ace. So out of 48 cards that aren't ace, we want 1. Okay? So that's the same as 1 multiplied by 48, which is the same as 48. So here's this answer, this answer. Okay? Now the last one is 5 cards in the same suit. This is called a flush. So 5 cards in the same suit. So in this case here, I could have out of 13, I could have clubs, 5 clubs, or, now anytime I say or, that means we add, or we could have 5 spades, or we could have, because there's 13, 5 diamonds. And I'm not sure which 3 suits I said, and there's one more suit, so add it. Okay? So now, these are all going to be the same number, so it's really just going to be 4 multiplied by 13, 5, combination 5. Okay? So now 13 combination choose 5 multiplied by 4 is going to end up giving me 5,148 as my answer. And that's how we do this first set of